Okay, like I said, everybody that wants to join can join, has joined. Tonight is going to be a review for the final exam. The review, you can ask questions about the topics, or you can ask for a little bit more guidance and clarification and coaching. But what essentially I'm going to do is to reveal to you the topics that will be on the exam. I'm going to look at a few examples, and we'll go through them, and then I will post those examples online. Nevertheless, the exam questions will look pretty much like what I will illustrate tonight, but also might include one or two topics that I did not illustrate, but the topics we'll cover during the semester. Okay, so I'm going to begin with I'm going to share screen so that at least you can see what I mean. So we may have a long session, we may have a short session. It all depends on what you want to do. So I'm just going to pull up examples. All right, so you can see my screen?
Yes, Professor.
All right. Okay. So, for example, I'm going to include in the exam a question on regression, on simple regression analysis. We'll also include in the exam a question on multiple regression analysis, but also a question on hypothesis testing. And hypothesis testing will be hypothesis testing for one population and hypothesis testing for two populations. And confidence intervals, and then some index numbers. Okay. There will be no question on ANOVA, okay, on analysis of variance. So let's look at a question like this number one. Okay, and let's go through what I expect you to do. Okay. Question number one. It says below is a summary regression results about the relationship between rent and size of dwelling. Okay, and so you will have a table like the one that I have here, which is a printout from SPSS, and it says write the equation of the relationship between rent and size of dwelling in square feet. And so here rent will be the and I'm going to color that answer. Okay. Okay. So the dependent variable is rent, and as you can see, it is here. Rent in dollars per month. Okay, that is the dependent variable, and so rent is a function of size. Okay, which of course you have A, which is the constant, plus B times size plus the error function. Okay, and so that's equal to the constant value here. As you can see, the constant is $177 per month. So the constant will be 177.121 plus 1.065, okay, times size plus the error. All right. So that is the equation I want you to write out. And you have to write it out in that way. Now, what does it mean? What does that mean? It simply means that the basic rent, and I'm going to actually, which implies that the rent in a house or apartment or a dwelling begins from 177.121 if it's a dwelling that has 0 square feet. Okay, and we can really see that these results here are actually are natural. They are expected. 177 square feet plus 1.065 times size, which is to say, for every 1 additional square foot of size in a dwelling, the rent will go up by $1.65. All right. Okay. So in this case, I also want you to write in the test statistics. I'm going to make this compact. I want you also to write the test statistics in brackets below. Okay. The t-value is 1.1. That is the calculated t-value. So these are the calculated z or t-values. Okay. These are the calculated z or t-values. These are the rho values. Okay. These are the p-values, and I'm going to paint it differently. Okay. Let's see if we can do a little better than that. All right. Okay. So those are the p-values. Okay. And I'm going to also put that the p-values that enable you to test for significance. Okay. So, but you can use the t and do your test. And below the t-value, there is 7.74. Okay. All right. So okay. So what does this mean? What it means, like we said, is that the basic rent begins from $177 for 0 square feet. Okay. And for each additional square foot, you pay $1.65. Now, the next question then is there a significant relationship between rent and square foot of dwelling? So what that question then means that you test a hypothesis that the slope is equal to 0. Okay, the slope coefficient is equal to 0, and this is the slope. Okay. That is the slope coefficient. Okay. This is the slope. So for each additional square foot of rent, so here you test for hypothesis that the slope is 0. That is what that question is asking for. Okay. You can take this and this is the equation here. Okay. All right. This is the equation. This is the answer to that. And here you're supposed to test for the slope. And how do you test for the slope? Of course, that means you have to state the null hypothesis. The null hypothesis is that B is equal to 0, which means that a size in square foot has no significant effect on rent. Which is to say, the size of the apartment does not determine the rent. Size has nothing to do with how much rent you pay. That's what it is. Because you're testing that the slope here is 0, which is to say that this slope, this size in square foot, has no significant effect on the amount of rent that is paid. Okay, so you must state the null hypothesis and state the alternate hypothesis that B is not equal to 0. Okay. That B is not equal to 0, which implies that size significantly affects, or you can say determines, amount of rent. That is your hypothesis. Okay, and so the next thing is to calculate T and compare T to critical T. So what is the critical T? Okay, so that means you have to specify a level of significance. So let us say we choose, that means we have to select a level of significance, which you have already, which you should know how to do. Okay, for example, let us say we select a 0.01 level of significance. Okay, and so Z star, the critical Z will be equal to 2.33. And please review for yourself on how to determine that critical Z, depending on sample size. That is, if you have sample less than 30, then you use a critical T depending on sample size. If you have sample size more than 30, if it's a large sample, then you choose a critical T based on the level of significance alone. So in this case, we're assuming a large sample, and the critical T is 2.33. And so the question is, since T of 7.74 is greater than the T star, or Z star, if you want to use that, of 2.33. So we reject the null hypothesis that B is equal to 0, and that size has no significant effect on rent amount. So let's correct that. Okay, and so we conclude that size of dwelling Okay, affects, or you can say determines amount of rent. Okay, let me use this opportunity to explain or demonstrate to you that the statistical analysis that you do actually reflect reality most of the time, and this is why we use it. As you can see, if you look at the critical t-value, if you look at the calculated t-value for the slope, which is this equation says that rent begins from 177.121 for an apartment that has 0 square foot. Well, have you ever seen an apartment that has 0 square foot to live in? No. Okay. So, but if you look at it and test a hypothesis that this constant is 0, you will not be able to reject the null hypothesis that that constant is 0, which means that this amount here really has no significance. You get the idea? So it reflects reality. If somebody shows you an apartment that has no living space, you will not pay a penny for it. You get it? Okay. Nevertheless, in statistical analysis, we do not totally ignore it. So question number 3, it says, if a house is 1,800 square feet, what is the estimated rent on the house? We nevertheless are going to use so amount of rent amount of rent 1,800 feet okay, the amount of rent will still be 177.121 plus 1.065 times 1,800. Okay, and what does that give us? Can somebody help us out? Yeah, somebody help us out.
I got 2,095, 112.
Okay,
Thank you.
did everybody get that? Hello, Mariam, David, what did you get?
Yeah, it's like,
Oh, sorry, go ahead.
yeah, that's what I got.
Okay.
Yeah.
All right. So 2,095. Okay. So let's just make it a round figure. Okay. So that means that if a house is 1,800 square foot, your rent for it will be about 2,095. That's what it is. This is an estimate using regression analysis. So if you are trying to advise somebody and you see different apartments, or even somebody advertised an apartment for you, you say, okay, I mean, you look at the existing data and somebody says, I'm renting this apartment for $3,000. Then you ask yourself what's in it, okay? Now remember that the size of the place, the size of the apartment or house or dwelling is not entirely determined by the size, okay? That is not the only variable, okay? The size, the neighborhood, the facilities, the ambience, these are the things that now you factor into it, okay? But this is an estimate of an average. Okay. Is that clear? Okay.
Yes.
Okay. So this is very, very, very clear. And so if you see a question like this in the exam, please, I want you to respond very diligently. Okay, I want you to respond very diligently. If I ask for the, is there a significant relationship? I want you to, tell me, first of all, that you're going to test a hypothesis that the slope is 0. Okay. And so you have to state your hypothesis, select your level of significance, select the critical value of T or Z, and then proceed to apply the decision rule. And I need to see you applying that decision rule. Okay. Okay, here's another example. The same kind of problem. The difference is that this problem, which I'm going to put on a separate page. All right. The difference is that this problem is on multiple regression, not simple linear regression. The first problem was simple linear regression, okay? And this other problem is multiple linear regression. So the same process you're going to do, except that you test each slope individually. You test each slope individually. These are the slope coefficients for each of the independent variables. These are the slope coefficients for each of the independent variables, okay? And these are the calculated Z or T for each of the slopes. So the question then will be for you to go through, if I said, state the coefficient of determination and interpret the meaning, okay? And in this problem, I did not disclose the coefficient of determination here, but if I give you an assignment and ask you to state the coefficient of determination and interpret its meaning, you should be able to state the coefficient of determination. And the meaning is what percentage of changes in the values of the dependent variable explained by changes in the values of the independent variables. Okay, this is what the coefficient of determination tells you. Okay. If I ask you for that, please explain that to me. And you're going to see the R squared, which is actually R squared. Okay. So that is your coefficient of determination. Okay. That's your coefficient of determination. So so when you see it, you know what it is. Okay. So again, for each of these slope coefficients, you have to go through the earlier process, state the null hypothesis, state the alternate hypothesis. Of course, you're going to use the same critical value to test all of them. And then take each of these T's to now compare to the critical value. It says, does the size class significantly affect the price of the car? Okay, this is the size class. Okay, this is the size class of car. Does it significantly affect the price of the car? You go through the process. And I say, what is the marginal effect of the size class of car? So in this case, the slope is what we are referring to the marginal effect. You can see how language is used to explain the same thing. Okay, slope And it says, what is the, if you go to buy a car, the age of the car reduces the price. As you can see, the older the car, the lower the price, okay? And so the, again, the more miles that you put in the car, the lower the price, okay? That's very clear. The size class, okay? And we put in the size class. Is a compact car, is a medium sized car, and what have you. So the size class affects the price of the car, and so the marginal effect is 8443. Okay. For example, the dummy variable here is size of class. 1 is equal to full size, and mid-size and compact is 0. So here, it means that a full-size car will add 8,443 to the price of the car, okay? Location of the dealer. Location of the dealer, 1 is Manhattan, 0 is Hempstead. So again, here you can see that we use 1 for Manhattan, which means that cars in Manhattan cost $2,000 more than cars in Hempstead. This is what this figure here means. Is that significant? Okay. Is this significant or not? That you have to decide. You use this calculated T to compare to a critical T and come up with whether the slope here is 0 or whether the slope here is non-zero. All right. So that is what I expect you to do. And if I ask for that, here I ask the size that is the marginal effect, that is the slope. You can see I asked 2 questions here. Does the age significantly affect the price of the car? If so, what is the marginal effect? Of course, you will tell me that yes, this, you test your hypothesis first to see if there's a significant effect. And then you will point out to me that, yes, the age of the car has a significant effect. And that's assuming that you reject the null hypothesis, that for each additional year on the age of the car, the price reduces by 1,476. That is what I expect you to say. Okay. So that is for that kind of problem. Here we have the owner of a nightclub has recently surveyed a random sample of so many customers. Would like to determine whether the mean age of our customers is greater than 32 years. Okay. Now, so she plans to alter the entertainment to appeal to an older crowd. If not, no entertainment changes will be made. Now, suppose that she found from a sample that the sample mean, which is the sample average age, is 34.5, and the sample standard deviation is 6.25. Okay. She wants to test the significance at 0.01 level of significance. So what is the critical Z value? The critical Z value, Z star, is equal to 2.33. This is a large sample. And I want you to look that up from your table. Okay. What is the calculated Z? Of course, now the calculated Z is what I want you to calculate. And so Z is equal to okay. This is X bar X bar. Okay, just give me a minute. I don't think I'm going to use that. Let me do it in a different way. Okay. Minus null hypothesis divided by S over square root of N. This is giving me too much trouble. All right. Okay. And so this is how you calculate. And so what is our calculation here? Okay. And our X bar is 34. 4.5. Null hypothesis is what? Okay. Null hypothesis is 32. And in fact, I missed a step. State the null hypothesis. The null hypothesis will be that mu, and I'm going to insert mu there. Now, you don't have to go through all of like using the right symbols, that mu is equal to 32, and the alternate hypothesis is that mu is greater than 32. Okay. Okay, so that's it. And then, of course, you would select your critical Z, which you have already determined. And so S here will be 6.25. And the square root of N will be the square root of 175. So now, once you do this calculation, okay, and so I want to see a decision rule. Okay, if Z is greater than Z star, you reject the null hypothesis. And so in this case, if you reject the null hypothesis, the question is, should the entertainment be altered? Of course, if you reject the null hypothesis that mu is 32 and conclude that mu is greater than 32, then the entertainment should be altered. If you are not able to reject the null hypothesis and show and conclude then that mu is 32, the average age of the patrons is still 32, then you will not alter the entertainment. And so this is what I need for you to answer that. Okay, but you must, what is the calculated Z? The calculated Z is the result of this calculation. Okay, and this is why I asked you the question, what is the calculated Z? Okay, even if I don't ask you for that, if you're testing a hypothesis, you must calculate the Z. Okay, I do not have to ask you for that. But once I ask you to test a hypothesis, then you have to calculate Z. Okay, and so this will be the kinds of questions that you answer. And this question is about the same, except you use a confidence interval. Okay. When I signed this question for an exam, it was an extra credit. So let me take it out. There'll be no extra credit. Okay.
Sorry, excuse me, Professor. I'm just quick. I have to go because my next class will begin, so I will be leaving this. But I will email you if you have any questions and upload any pending assignments.
Okay, fine and good. Okay.
Thank you very much. Thank you.
All right. This question calls for a confidence interval estimate. Okay. So you will have a confidence interval estimate in the exam. Okay. And this question calls for index number, simple index. I'm not gonna get into the more complex index number calculations. You're gonna have a question on a simple index calculation. All right. So this is about it for what we're going to be looking at in the exam. I might include a question on hypothesis testing for two populations. Please work on that also. Okay. Hypothesis testing for two populations. Even though I didn't bring it up tonight, but you might have a question on hypothesis testing for two populations. So this is it. If you have any further questions, I will answer your questions. Otherwise, I am done for the night.
So this is all we're getting, or this plus multiple?
Hypothesis testing for two populations.
Right. So this, what you just showed us, is the exam.
Well, not these questions, but this,
Right,
yes, that is the exam. Yes. Yes.
Right. So
Plus,
that, we still have to do multiple choice questions too?
yes, there will be multiple choice questions. Okay, so the exam will come in two parts, a multiple choice part and a written part.
Okay.
All right?
Yeah.
Okay. Remember, there was no midterm exam.
Yeah.
Okay. So
I have a question.
Yes, go ahead.
In your email, you had said that you were going to add 3 more points towards the final grade. I wanted to know, like, how exactly is that going to work? So, for example, is it going to be, say, I have a 88, you're going to add 3 points to make it a 91?
Yes. So I know
Okay.
that Mariam was here, and I know that Charlene was here, and I know that David was here. So each of you will get 3 points added to your average for the class.
Okay.
All right.
Thank you for that. Okay.
Okay. All right.
And plus the 10 points as well, or yeah.
Yes, plus the 10 points added to the exam.
Okay.
Okay.
And also, sorry, one more question.
If you get 90 on the exam, you get 93. That now gets into your average. And after I calculate the average, that will include the homework assignments and what have you, and the quizzes, then you get 3 points for being present today.
Okay. And also one last question. So the entire final, is it out of 100? Is because I believe that you said that in your email we're gonna have like 4 or 5 questions that is gonna help with that.
The essay part will be 100 points. The multiple choice part will be 100 points.
Okay. And then for the
So that means the
short
final
response-
exam will come as 200 points.
Okay, okay, okay.
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 Thank you, that's all.
All right. Any other questions?
No,
Okay. All right. So enjoy your evening.
Hi, Professor. Thank
you as well.
All right.
Thank you.
Well, are you
Oh,
saving this
are you
one?
gonna upload? Yeah, I was gonna ask, are you gonna upload it to Blackboard?
Yes, I will. I will upload it on share. What do you call that thing? YouTube,
Yeah.
and then
Oh.
I'll give you the link through Blackboard.
Okay, thank you. That'll
Thank
be a lot
you.
helpful.
All right.
Okay, good
Okay.
night.
Good night.
Bye.